a very interesting thing happened a month ago. That was like gravitational waves were for the first time materialized, and we could listen to them, and we can actually have a visualization of that audio signal. And basically the idea is that, many hundreds of years ago, this guy, Newton, an apple fell on him, and it basically gave him the idea that there is something called gravity. Now, what is gravity? How does it work? What are the interrelationships? Nobody knows about it. But yes, there is something called gravity, and that basically, opened up the Pandora box of a huge plethora of knowledge in sciences. And then 100 years ago, this guy, Albert Einstein, basically gave up a theory called the Theory of Relativity, where he says that gravity has basically some interactions with time and space. It is not just an entity in itself. It basically interacts with something called time and space, and it can warp it. In other words, it can interact it and change its behavior. And just recently, in a matter of weeks, an American institute called LIGO in two different you can say locations within the US actually proved that yes, Einstein's theory of relativity, where he specifically mentions this thing, is correct. So my fundamental reason of presenting this to you guys is that science does not need to have all the answers on the first day. It progresses over a period of time till the answers emerge, till even the requirements of what we are trying to find emerges. We don't know our user requirements when we start up a project, but as we go towards this journey of implementing and of discovering this, we find more answers and things become clearer, and then we can ask the right questions. So science fundamentally, inherently has been very agile. But what we talk about science is that we have to be very clear that science is a scientific process. This was the funniest tweet, in my opinion, of last year, where somebody mentions that let's make 2016 to be the year where we remember science as an investigation method and not a belief system. And pretty much this investigation system is empirical by nature, and it is agile by design. So let's thank off all our sponsors for this event. It's always good to be here. This is the third time I'm here to this same conference setup. Second time for Agile Middle East. The list is growing all the time, which means that the community is growing as well. Myself, I'm Atif Abdul Rahman. I come from Saudi Arabia. I was born in Nigeria. I was raised up in Saudi. I've spent time in Germany. And when I first entered into the US, a lot of red lights were going around in circles. That was their particular, you can say, algorithms were not working. So basically, I classify myself as an outlier. I work for a telecom company in Saudi Arabia in marketing analytics. I work for them in promotions and campaigns and creating growth hacking strategies, as well as sometimes I also work in creating data as a service and also doing data monetization projects as well. So more about me is not that interesting. What is more interesting is this big elephant in the room, which we have to get out of the system. So what is that elephant in the room? Can anybody guess that? When you entered this session of Agile Analytics, you had certain perceptions in mind. So what were those? Can I hear some feedback? Why are you here? Anyone? It's not a philosophy question, once again. Yes?
Velocity number, I don't know any of the numbers which we are measuring with what's the progress over all the actions spent and how we evaluate it. The main thing we have is velocity and how many tasks get completed. So I was interested in knowing more about how to measure, how to do analytics on the agile thing.
All right. Anybody else? Yes?
To be inspired.
To be smart.
To be inspired.
Inspired. Okay, that inspiration room is on the other side, actually. You still have time to catch that one. Anybody else? Yes?
Keep in touch with new upcoming things.
Okay, this is as old as it can get, by the way. Sorry to disappoint you. Analytics is very old. It just, sorts of changes across its time.
Agile is really young, and I know it quite well. And I know analytics from completely different sets.
All right.
Of I don't know, area of application where I was working, so I just see how I'm going to connect those two.
Fantastic. I mean, this is good.
The right KPIs to focus on to accelerate transformation.
Right KPI to find to accelerate transformation. All right. Very interesting. Anybody else? Right. So as we can all understand that we are living in a very constrained environment, and our constraints are both bound by time and space, unless we have some capability of Einstein's gravitational forces. we really have to scope our session to something very specific. And as I can see from the discussion, we have a lot of very different ideas of what this session is about. So I spent the last couple of 4 months trying to plan this particular session, and eventually I decided that what needs to be delivered is what's on that day, what people are really interested to listen, and based on what the audience of this conference is, which is an Agile conference, so we will talk about how we can deliver analytics projects through Agile. And does it really make sense to deliver analytics projects through Agile? And do we really need to make some changes as compared to a traditional software development project as we deliver it through Agile? So that's the elephant I want to remove. The other animals that we have, let's try to address that within the limited time we have or not. But that's basically the fundamental thing that I want to talk about. Most of the questions people have asked here, or they are expecting from the session, eventually would lead up to discussions around BI bureaucracy. So anyone who hasn't heard the term BI before the session, of course. Business intelligence. Yes. So business intelligence was a term coined in, I think, roughly around the 90s, where people said that we can have systems where our business operations and our business behavior will be governed by intelligence coming from systems, and they will be working as our support systems, where we can find insights without really having experts. And eventually, what eventually became was that business intelligence solutions became more of an information delivery problem rather than an insights generation or an intelligence generation problem. So what currently people look, when we think about BI, is we talk about things called scorecards and dashboards and questions like the gentleman asked, that what is the right KPI to measure that will drive my business performance? So eventually, that's a specific problem that happens. But when we're trying to resolve these problems, we find out that a lot of this eventually leads up to failed projects, eventually leads up to very timely investments in human resources, in understanding the problem statement, and also in trying to understand how we can get these things delivered. But in practicality, I think this thing is not working a bit. So, but in practicality, we find out that there are 3 fundamental things that eventually did happen because of this BI, activities. First and foremost, that one of the core technologies behind business intelligence, or one of the foundational infrastructures we used to make, were data warehouses. We believe that we can actually model and design our organizational business processes and their behaviors into very nice, purist sort of data models that can give all sorts of KPIs, metrics, and all sorts of metrics. And we can also do feature engineering and create new metrics, and all will be modeled, and then business stakeholders can just come in and just get any sort of information in any sort of view they imagine from this data warehouse. But what has happened is that the way these data warehouses have been designed and have been led have become a very fragmented sort of an approach. Another problem that we basically have seen with these BI systems is that there is a lot of lock-in that happens because of vendors. These technologies are not are pretty much based on vendor-specific platforms, and even the code base and the intellectual property we have been building on these platforms have been kind of locked into it. And till today, there are products out there in the BI space where you cannot even do basic version management or version control of your source code. And deployment does not follow a similar track like you would do in a typical application development lifecycle or not. So, and the third problem that has happened because of this that Tim also mentioned in one of his sessions before was the curse of consultants and the curse of armies of developers and outsourced resources. So how can you convert a simple business problem into a really big project outsourcing problem and hire armies of developers and resources and make them work in stacks and make them work in very fragmented input-output groups and start off thinking in terms of, okay, a rally race or a relay race? And that's exactly what has happened in the BI world. And when I talk about these fragmented architectures, this is the one I'm talking about on the right. So we always thought in terms of these stacks, that everything is separate. There's a separate concern of systems, there's a separate concern of integration of this data, a separate concerns of the modelers, and then on and on. And we've always thought of this problem as a BI problem as a relay race, where one person will give the baton to the next one, and while we are waiting for that person to come and give us the baton, myself and my 3 other teammates are just waiting and doing nothing, and absolutely nothing. And that's a lot of waste. And since you have attended all of these Agile sessions, we don't want to talk about it. And this has actually been happening till the early 2000s. And then around 2005 and 6, there was a paper in knowledge discovery, in SIGDD, which is a special interest group for knowledge discovery and data mining. Google folks basically released a paper called MapReduce. And then Yahoo incubated that research paper into a small team, and this made a prototype application. The guy who was leading this initiative actually found a name for that, and that was the name of his kid's pet elephant. So he called it Hadoop. So Hadoop happened to the world. And what Hadoop basically did was that he actually, for the first time, as a very big impact, opened the possibilities that we really don't have to do business intelligence the way it has been done before. We can actually do something quite different. And as a result of that fundamental change that has happened in capabilities as well in terms of delivery, you can see now today there is a huge, huge market space of these vendors that are doing something around what we call as big data. And this is basically a version 3, version 4. I've seen the draft of that as well. So what really did Hadoop do? Or what really did this big data phenomena do is that among a lot of other things that you might have heard about the volume, velocity, and variety. Anyone who hasn't heard these 3 V's of big data? All of you have heard that, right? It's cliche to mention that again. But volume was always there. Our capability to process systems was always behind our capability to handle data. Teledata, when it first launched its 5 megabyte hard drive, that was a sensation of its time. That was a breakthrough technology, right? So, and velocity has always been the case as well. Variety, you might argue that now we are creating a lot of new type of content and a lot of new type of multi-structured data. So that might be something unprecedented as before. But nevertheless, we were able to look at this as the same problem statement. But what has fundamentally changed here is that now everybody can have that capability to create up let's say a cluster of computers, put up a very difficult or a hard problem at it, and instead of having a supercomputer, very basic utility computing environments that you can have in your homes, or you can even have from the cloud services, and you can scale a problem into something as a solution. So, so practically speaking, a person in his garage room or his apartment in Dubai can actually start up a whole company and can become a millionaire overnight based on the type of capability and the hardware he has. And this hardware is now being utilized by software, which is this big data technology stack, that solves basically the same problem by segmenting these problems into other very unique specific problem statements. So before everyone was thinking about BI as the same continuation of relational databases. And relational databases were always used by application developers. It's very good for transactional property, referential integrity, and blah, blah, blah. But we always start to extend that for analytical needs. And then when we tried to do that, we were always solving the problem as Henry Ford's problem. Back when Henry Ford created his first automobile, engine-driven automobile, people were trying to optimize the carriage wheels and the carriages with horses. They were trying to improve the whole experience on horses, whereas Henry Ford came up with this new automobile that could do something different. And because this community just picked up like crazy, and there were some really smart companies behind it, none of them, I think, enterprise, all of them were internet startups like Yahoo's and Google's and whatnot, that now everybody is looking at the automobiles rather than the horse carriages. So we can do more with our hardware. Most of this technology, thanks to the stars being aligned correctly at the right time in this part of human history, that most of this is open source and driven by open source communities and incubated. It has even been to the level where there are commercial companies that are primarily now open source commercial companies. So that model is no longer a theory. That model is now in practice, and it is quite significant. And also, because of these sort of technologies, so people like myself who work in the marketing department, we don't have any dependencies on IT any longer. All we need is a server space on a cloud, and then that's it. It just gives us the capability to create our own infrastructure and start doing our own analytics. And this is fundamental. because the way IT has been doing, as we all have experienced on and off in large companies, is that we are tied behind a lot of bureaucracy of procurement, IT purist mindsets in terms of cleaning and owning the data and processing the data themselves and then giving you just parts of it because of privacy or security paranoia and whatnot. And when it comes to the business directly, then you basically have that ability to sit closer with the business and run hundreds of hypotheses and test them out. You can prototype like crazy. That wasn't there before. And this capability to really prototype faster and create solutions faster is the foundation of what I call as the democratization of this infrastructure. And there are now more capabilities that are building onto that. Now, since this democratization has started, marketing has caught up, and whenever marketing catches up, it's always a bad sign. Then that means that the technology is going to be added up with a lot of noise. And one of the noise that we've been hearing from really respected organizations like Forbes is that data is the new oil, whereas data has never been the new oil. The oil has always been insights. You cannot sell data itself. It's a raw material. You can't really do much of it that. And what has happened is that people, all right, people have been so much obsessed with this love affair with big data and everything that is around with that they're starting to just accumulate and started to do a lot of these weird projects around big data. So they don't really know what they're doing with this. They just know that somebody's doing it. So, the FOMO, who knows FOMO over here? Fear of missing out, right? So because of the fear of missing out, since everybody else is doing big data, so let us also do big data. And what has overall happened is that we have so many of big data projects, but very little of insights that are coming out of it, or very little of tangible value coming out of these projects. So what I want to basically move towards is the rationale that big data in itself is not the new oil, but it is finding the value within that big data that brings true benefit. Nate Silver, he's the person who quite superbly predicted the last US elections. He runs a blog, he's a statistician by religion, and he basically mentions that it's all about finding the right signals in the truth. So what big data does is that it starts adding more and more noise. So if I am in this room and I'm listening for something, let's say I want to listen to the word Tim, it's far easier for me to listen to in a crowd which is smaller rather than go into a stadium and then try to hear the word Tim. So the more the data, the more noise there is, the harder it is for my algorithms and my techniques to go and find that true signal out of that. So this is the fundamental argument that we have. And just to close this off, I'm not ridiculing big data, but I'm basically trying to put a point here that businesses and stakeholders don't really know what they want as a requirement. I'm going to talk more about it. So it is pretty much like a subject that nobody knows about, but it's a very hip topic to talk about it. So what is big data in terms of, we're talking about that there's huge influx of data, Internet of Things is generating it, there's this much things happen on social media, a lot of junk happens. We call it like the cyber junk. People taking Pinterest pictures or pictures of their food on Instagrams and doing that. So it actually adds a lot of noise, and the noise keeps on adding. And then when businesses come and then basically say, hey, we have a lot of social network data. Can you Mr. Data Scientist or dear team, can you go and just find some value for us there? That's the user story they're basically putting in an agile sort of or a Scrum sort of a framework. And that's the problem where it starts to happen. And people always ask us this question. When are you going to predict the future? It's too late. Your solutions are too late. You're just doing some number crunchings, but we're still waiting for that golden nugget. And the fact has been that we have been trained or anchored in Dan Ariely's mindset to deliver projects the way traditional BI has been delivered, not as the way as a Socrates or a Plato modern version would do. You have to ask 20 million questions before you can really know that you are even asking the right questions or not. So, but there is some hope, and one of those hope is that this is the Gartner's hype cycle. It's I like it very well. It works really good on marriages. Other than that, it's two years ago, big data was all the hype, and as I said, marketing, when it's a hype, you should basically get off of it, let it settle down, and that settling down phase has already started. Now people are coming to a point where now they're going to start disbelieving in it, because already last couple of years, huge amounts of investments have been made, and we haven't seen much happening in those investments, except for a few outliers. Most of the organizations around the world are really trying to do some sense making around what is that real value we are trying to capture. So what is really picking up right now is this field called analytics, which is not a new field. It is as old as humanity. And what analytics does is that it's nothing more or nothing different than what you guys are already aware of. It's empirical process control, right? What we do, we start with experimenting things, which we have an understanding that we need to do something, and then we try to articulate that problem into a data problem, and we try to figure out what are the data sets that we can actually use to address this sort of a problem. And then we go through these rapid cycles of experimentations by creating these models, testing them, failing them again, then creating a new set of data set, running that across an experiment, testing them, then failing them, then trying a third time, till the time comes that we really come up to a conclusion, not about the problem statement we might be solving, but even as simple as formulating the right problem itself. So what I'm trying to say here is that analytics itself is inherently agile by design. And this is basically a non-data driven pattern. It's not based on research or something. It's basically a rule of thumb or a heuristic that the data community talks about. So what it basically says is that the index is an artificial index score. It's not something specific, but what we try to show is that we have a very strong understanding in analytics that just by investing little bit amount of efforts, you can achieve a lot of value out of that. So the 80-20 Pareto Principle, just by doing 20% of effort, you can release 80% of the worth, and most companies will be fine by that, and most organizations and most problem statements would be fine by that. It's only when you really need to find an optimized performance or an optimized value, at the end you might be doing that. So these are the problem statements of Google's and the Facebook's. They are basically working on that last mile of that 99% accuracy of models, or 99% quality index of their models. Whereas most business people are talking about the basics over here. Some gentleman mentioned about their app, and they, or not even their app, their agile processes itself internally. And they want to figure out how their breakdown charts are doing and how they can improve that. Just by looking at that fundamental data and just by enabling that data in the right ways, you can actually achieve that sort of a value that goes into that. So inherently, this is again supportive of the agile mindset and the agile frameworks that are out there, extreme programming or Scrum or whatnot, or DSDM or whichever flavor you like. All of them, by and large, would be supportive of this mindset that you can start with very basic questions, and then you can start getting very basic raw, or you can say a little bit of rough answers, and then from there on you can go on and refine your questions and go on and refine your answers accordingly. And so again, 80% of practitioners, I don't like to put statistics here. This is the only one, I promise. TDWI, the Data Warehousing Institute, it took them a lot of time to come to this agreement that yes, Agile is an approach to deliver data warehouse projects. They were in denial for the last 10 years, and now they're trying to catch up with the big data world. So now they are sheepishly releasing these sort of figures and sort of reports that satisfies us, Agile community. So inherently, we know the four manifesto principles here: individuals and interactions, data science and analytics is basically a team sport. You cannot work in isolation. You need to have people of multi-backgrounds, business domain knowledge, good in maths and stats, good in programming, good in data engineering, which is like building up this large server environments, pulling up data, reshaping it, munging it, throwing out here and there. User experience people are sometimes needs how these numbers or these insights are going to be consumed by people. How does it make sense? If I tell somebody that I'm making a churn prediction model as a telco, I want to figure out when you are going to leave our company as a customer, and I give you a score that there is 86% chances that Jürgen will leave us, what does it really mean? What does 86% actually mean? How do you consume that sort of information, and how do you as an individual take decisions based on that information? So user experience comes as part of that, where we're basically what we try to do is to figure out how do we do sense making of these numbers, and how do we translate these numbers into something that people can take action on. So it's inherently not just the math geeks in one corner of the office. It's basically the whole spectrum of company that comes into play. So it's very much about interactions. It's very much about these sort of questions that go on and off. And there's a lot of decisions that happen based on how you would like your results to be out. If the user experience stakes basically say that presenting a number like 86% is not really consumable by our audience, then that basically forces the whole team to go ahead and redesign a different algorithm or use a total different technique to come up with something more explainable, right? Right or no? Yeah. So in that case, it is like that. And then second thing, we always talk about working models. So there's this joke that a friend of mine shared. I cannot disclose his company. He works in a very big company in Dubai. It's a bank. And they had a lot of pressure to determine a model to identify value at risk estimations. They use this for investment banking and stock value predictions and stuff like that. So the company was pretty much, you can say a top-down driven sort of a mindset that the big boss says that it has to be done, so it has to be done. The whole company is awake at night and they're trying to run through these numbers. And already their market is very fast moving. It's a stock market, so you really can't wait and think about it. So they make an algorithm to predict this VARC score. And it was running for a lot of months without any problem. Then one day it just crashed. And when they started to diagnose that, the people who actually made it knew that they have to leave the company before somebody opens this up. And it was pretty hilarious, he tells me. He says that eventually there was just a random function call inside of that. A sophisticated series of random function calls. So it's as simple as that. You want to make a coin toss, right? Coin toss, yeah. So, so basic statistics 101 says that if you toss a coin like a lot of times, right, the expected value is that over a long period of time, it will come down to 50% heads and 50% tails, assuming that your experiment is unbiased, which means that the chances of having a heads and a tails are equally likely, then eventually you will reach 50%. So if I can make a model that can do slightly better than a 50%, I actually say I hacked a model. That's a hack, right? And that's where you see this data science diagram where, on the internet where they see that you need hacking skills. This is exactly what they mean about it. Sometimes things don't really make sense, and sometimes people do these crazy things just to make models work. And then what you do is that then you try to make it more sophisticated in the sense of being more robust, being more capable of working in different environments. What if that the same algorithm can be taken out of the Dubai stock market and put into, let's say, a Frankfurt DAX or put into New York Stock Exchange? Would it similarly function or not, or would it break? Because the data is different, the behavior is different. But what happened is that instead of doing a traditional waterfall-like mindset that, hey, I need to have this X amount of money, and I need to do these projects in this 1, 2, 3, 4, 5, 6 steps before I can lay down my infrastructure, then I'm going to do something about it, and then that something about it would not really be useful or not, I'm not really sure, because you don't know the problem statement, I don't know the answer statement, so let's try that. That has been happening for a long period of time. And then what this approach says is that, hey, we still don't know what we're doing, but we can give you something to start with, right? So if I ask you today that when you find a route to go to your homes or your hotels back from this conference, do you actually go and get all the feeds from Google, from your telco operators, and get all the maps of Dubai and lay it out on a very intelligent sort of a network, and then figure out what is the best route for me to save, let's say, a few minutes of time? Let's not go into how much minutes or not. You won't do that. You will use heuristics. You will use basic estimations. Okay, this much is fair enough for me. This much range is good enough for me. If I reach home instead of, let's say, half an hour as a typical time, instead if I can reach within 30 minutes to 35 minutes, I'm still good. Then that sort of a easing up of constraints would help me take very simpler decisions. All right, I'm just going to pick up a cab and that's it, go home. Let the cabbie decide what route he's going to take. So that's basically what analytics doing in an agile approach basically would do, is that you are always having a working model with you. When anybody comes up, you always watch that. So there's a very funny American TV serial called The Consultant. Anybody seen that? So what happens is these guys, McKinsey sort of guys with ties and suits, and they walk into this office and they're discussing with all the shareholders about this company valuation or whether they should sell this company or they should do something else. And this one consultant, he's partying all night the before. And on the day of the presentation, and he just pulls up this amazing deck with very flashy graphs and charts and you know, everybody looks very impressed, or they're bedazzled by this guy has so many fancy charts. Ooh, look at the colors and all that. And then eventually, this one smart guy in the room from the client side just say, hey, wait a minute. Where did you get that number? So the consultant comes back and he says, FMA, FMA. So the guy gets quiet, the client gets quiet. Okay, FMA, it's a technique I don't know of, so why, shout out my ignorance, non-agile setups. So the person, shuts up, and then they finish this presentation, and eventually the prodigy comes back to this master consultant presenter, and he says, hey, where did you get those numbers? I saw you were partying out all night. How did you get the time to do this? He says FMA. He said, yeah, what does FMA mean? He said, from my arse. So numbers are basically fundamentally, you can say, used or misused against you. It's all about what you're trying to achieve with that analytics, right? Customer collaboration. I'm going to talk more about this point later because we are really short of time. Responding to change, of course, models should change unless there is no reason to have a model in the first place. I'm again going to skip this point for later. So there is a growing movement within the data community by the rise of this new genre of technologies. I don't want to really burden you with a lot of jargons, but this new jargon is again the only one I'm going to tell you. It's called data unification. So what these data unification vendors within the whole big data spectrum of these vendors and tools are doing is that they're saying that, hey, we can convert your DevOps-like mindset to and apply that to data and make data ops. So it's not just agile, it's going more towards lean and more towards those sort of things, the continuous delivery and continuous value extraction. And so what I'm trying to say is that there is this growing demand and there's a growing recognition that these techniques have a very good potential in markets like GCC, where we have a huge amount of opportunities in the areas of big data and analytics and data science and whatnot. And there's also not just these areas, but traditional application developers now want to make their apps more intelligent. Uber as a company relies on that algorithm that does pricing. It's not really a company that came out with this idea, hey, let's find a taxi service on an app. It's just not that. It's basically the pricing model that makes them come up and their competitors killed. And that pricing model is a data science problem, basically. It's an analytics problem. So more and more we are going to find data scientists among application developers or teams that are working around apps. And more we should be realizing that there's going to be these clashes with data scientists in the way we actually interact with them, in the way we actually have our expectations set. So I have this makeshift presenter. So what are these data science creatures? They are fundamentally agile by nature. We talked about the hacking skills, the guy who just does the random function generator. Maths and stats knowledge will never be bad. It's not that maths and stats knowledge that you got in your high school or college, but it's more fun maths, I would say. It's more interactive in that sense. And then you need to have substantive expertise or the experience of the domain knowledge that you're working with. So if you just pick up a data scientist who's working in, let's say, the financial sector, yes, there are a lot of those data scientists who actually can work from that sector and move into bioinformatics, for example, but the chances are very, very low that he will be operational or effective from day one. That person needs to have substantial knowledge. But that knowledge would not be enough. You need to have real biostatisticians sitting with them and real bioinformaticists sitting with them, and in the world of finance, real financial analysts sitting with them to have this sort of teamwork. And this is exactly what Agile has been trying to do. The fundamental difference has been that in application development, we always say a business stakeholder. We don't care if he's coming from finance or marketing and sales, as he's part of the process who's using my application as a workflow engine or something else, right? Whereas in data science and in analytics applications, this person is actually the key driver of what's happening. So his actual job is heavily dependent on what he's trying to do over here, and so does ours. So it's a more tight coupling between the two domains. So every time it locks my keypad, and then I have to open this up. So let's take an example of applications and that are built through Agile concepts, as well as analytics that is done through Agile concepts. And what is the difference between the two? We have talked a lot about Yes, there are a lot of similar things that analytics projects can learn from the Agile community, and some of you might be really interested to get more into Agile because it really fits your belief system. But on the other hand, there are some differences that we're going to talk about. Now, this is a recommendation engine, one of the most famous recommendation engines from Amazon. It just tells you that if you buy a book, you will get another book. So I'm just going to give you a trick question so that I see if you are still with me or not. This is a recommendation from one book I chose. It gave me these 5 recommendations. Which book that might be? Just a guess.
Agile Analytics.
No. Who said that? You got it. Yes, it was Jürgen's book. So, and what happens with this is that if you talk about user stories or sort of creating an application concept as a recommendation system as an application, your traditional life cycle would be that somebody comes up and you do these whiteboardings or whatnot, and you come up with these user stories and you say, hey, we need a feature that basically gives us the top 5 most commonly used or purchased books that people buy when they buy the book X, for example, right? And we need to have the ratings displayed, and we need to also have some basic metadata around which one is the bestseller or not. That's an application user requirement or a user story. When we come to the Agile world, what happens? How would an Agile analytics requirement be formulated from this sort of a problem statement? Anybody, just wild guesses. How would you define this as an analytics problem?
What's like calculate the likelihood and then assign the likelihood to all the book commands.
You said
The story, you will define story just like you will define story in Agile. I thought you were the Agile or like analytics versus a feature.
yes. Excellent. That's what I wanted to know. Anybody else? I'll come to that point. Yes.
From personal experience, what we usually what a number like that, one of big banks too, they look at the process, it's closer to receiving partners, etc. They see how they do that, for example, what the credit card company. They look at customers, rewards, points, etc. And then we look at how we can apply analytics to accelerate the increase the span of time. But once looking at the process and then redoing it again using the new technology stuff, that worked well for us actually for an awful lot.
Perfect. So what would you say was the problem statement? Using Hadoop as a technology to do something, or the problem statement?
Even what you'll see on the technology, this one is the best. I don't know on technology stack. We just started one process at a time.
Yeah.
Identify the dependency in the data, and then we got from different sources. They had MicroStrategy, we have open source leaders, and they had Pareto Principle, etc. And then out of that, we came with open source project in Japan. Looked at, for example, untitled transactions or automated increases to increase the experience of the customer, etc. So that's how we went about step by step, process by process.
Okay. Fine. I'll answer to that with the any other comments that we need to have. Anyone else? Any other opinions about what would be an analytics user story from this as compared to a feature user story? We had 2 answers. We had, and answers are always good and bad. It's not a problem. Just we need to do many iterations of that. So it's not a trick question. It's very easy. I mean, just what you think about it. I mean, you really buy books. Think about it. What would be an analytics question in here? A user requirement as such. We did talk about the how in your point of view, that how we are going to do it. But that's not really what we're trying to do as a user story. That's a developer's call, how he's going to develop it. Or she's going to develop it, yes.
Yes, an interesting question would be, what books are interesting for the person who wants to buy this type of books, and what books relates to this type of books? Yes, I could
Well, actually, it's probably the correlation between parts that contain the same book.
So these are excellent points here. Now I would like to answer that before we move to you, because yeah.
From the perspective of the user story, but really user story thinking like, I as a user would like to see the best book from the same area, description or whatever. That's the book that I have selected. So, yeah, that would be in the form of the user story. And actually, this is something that I would give to the developer or to myself, and the developer
So, can there be another user who comes up and says, hey, I just don't want to read the same books every time. I don't want to read all the same books that looks familiar with the same one. It's pretty boring for me. I want to find something totally new. I want to discover and go into the jungle and find a totally unrelated book. Could that be a user story as well that is different than that user you have in mind?
This one, let the first two selection be similar, third middle one, and the fourth with the lowest correlation or something.
I would create a different story, like the system could be like stuff like that can be a different chore kind of thing. Like create profiles for users and based on those profiles give suggestions.
So you have personas, and then through those personas, each persona you're saying, okay, this is the case. How would you decide that for Atif, I'm going to choose persona A, and for Jürgen, I'm going to choose persona B? How would you choose that? Or how would you go into that?
The data collected about you already.
How?
Books that you bought before, books that you did before.
Yes, so if you see that the books are very different from each other, then you would say he's persona A. If the books are very similar, you say persona B, something like that? Yeah?
Hopefully you will predict if you have the base of the previous users, how they have behaved, you can probably guess how the next user would behave.
So I sense two things here, basically, from what the audience is saying here. So one thing I understand, or what I'm learning, is that what you're saying here is fundamentally that our own perception of what the user story is depends on a process that we need to undertake in order to come and refine that user story itself, as compared to just a feature that I just need to see the top 5 related books. So it's not just the feature itself. I need to really refine the question of the user story by doing analysis itself, by doing what I was about to do with that user story itself. And second thing is that I really have to make a lot of assumptions in which type of user story I'm going to cater to, or what that sort of make would look like. Yes, we have these techniques in features that we can divide these based on personas and all, but what is fundamentally different here is that here, even I as the master, custodian of these user stories, am not even able to articulate what my problem statement is. You mentioned the word likelihood, somebody else mentioned the word correlation, right? It's basically you're trying ourselves and putting constraints and say just use this sort of techniques or mental models to solve this. But then the fundamental question is not that. The fundamental question could be, one of the user stories could be, or that is tied to a business goal, is that I actually want people to buy more books.
What are the most probable books that the user will buy?
Yes, right? Eventually that might be the case. But then there might be a conflicting goal at the same time from another department who has another KPI, is that would say, hey, don't cannibalize book sales, because that will hurt some authors. What cannibalization means is if if my algorithm basically always pushes me towards this bestseller, then these poor little chaps over there, which are fine books in themselves, would lose out that opportunity on that click, right? So there is this additional overhead of this, or this responsibility as we as Agilists would have, is that not just we need to now deliver this feature, but we need to really understand that user case by actually going through that experience of defining it. Which means that we would have initial level, like a lot of people in Agile, they say that, hey, we need to have this architectural sprint, or somebody says that, architecture emerges, so we're not going to do that. We're just going to start these initial 2 or 3 sprints that might not have that production release. The first release will come out at the 3rd sprint, whatever. So something similar we would have here, that we will have these initial sprints sort of things, if you're talking about Scrum, that will just simply go about and defining the problem statement by actually giving you workable models to play with, right? So after that, then you can come back on the whiteboard and say, now we are ready to start the user stories. So you're essentially starting 2 steps behind the application developer's life cycle. You have this additional step of number 1, defining the user story more concretely, tying up with what your product or your objective is. And number 2, you would really have to figure out whether you have the means in terms of your data to actually come up and refine that story. So I'll give you an example. Somebody, and this is a true story, these are called super forecasters, and there's a very amazing think tank in the US where what these guys do is that they try to predict big events, or what we call it as black swans. There's a very interesting book called by a Lebanese American called Nicholas Nassim Taleb, who really proposes that we are really good in predicting the normal activities that happen day to day, but we are really bad at predicting unseen events, right? Like the 2008 stock crisis or the credit crisis. So what this super forecasters do is that they answer questions like, what are the chances that, for example, a country in Northern Africa will move to anarchy? Or what are the chances that somebody else will overtake China in terms of mass productions of very interesting manufacturing goods, whatever. Those sort of questions that have far difficult consequences in tracking back and figuring out what needs to be done. Or, for example, the gravitational waves example that we started our talk with. Nobody knew how to solve that problem. Nobody knew how to even define that problem that we are going to use to closely or specifically placed mirrors, and those mirrors are going to see the differences in lights, and we will use this knowledge that lights basically travel and they bounce back as well. So we will find these differences, and we will know that we heard something, and then we will translate that into a signal, and that signal is something we can be sure about. So it's a lot of steps that we needed to do. So this is fundamentally different than a traditional app thing. And then also the value that we associate with models is also very, very difficult. I'm very sure that after 2008, there was a movie called Margin Call. Anybody watched that movie? It's not as famous as Big Short, but it was pretty good. So what Margin Call does is that this famous data scientist, he's a physicist by profession. Most of the data scientists are interestingly physicists I'm seeing. Basically, a day before or 48 hours before, he predicts that this is going to happen. So he basically tries to minimize their losses of their company by this cataclysmic event by basically getting out of the market and selling off everything they had on derivatives and these third-party products that did not exist. So what he does basically is that he basically justifies that the company who has invested millions of dollars in risk management and risk prediction software systems and these credit crisis and credit risk systems were not really worthy of that investments. And that's basically, they could not predict these things. And that happens on a daily basis. I can buy a recommendation engine today from Azure, from Microsoft's cloud or Amazon's cloud for free, and that's like a democratization of what data we talked about. But then that model would not still tell me anything useful if I put this in production. Whereas if I deliver a feature, it's delivered. The Uber car comes. But does the Uber car pricing model is good enough or not? That's very, very hard to really to link with this implementation of this, if I may call a feature, an analytics feature, right? I don't know if my Uber company is really working well because of the pricing model itself, or that pricing model is doing good or not, because it's very hard to do this correlation and causation sort of a thing, whether this thing is correlated with this or not. First of all, I'm looking at very large data of months and months of my business is running, and then there are third-party investments coming in. So in other words, there's a lot of noise coming in. So it makes the problem of Agile, if you're using a traditional app development lifecycle, very, very difficult to apply here, right? Would anybody disagree still after these arguments? Perfect. So how would we go about with dealing with them? You are a data scientist, or you are in a team which has a data scientist, right? Let's have some sympathies with that person and see how we can actually live together and develop awesome products and services. So this is a person who writes a very interesting book called Agile Data Science. It's on O'Reilly. You can easily get it. One of the funniest speakers I've seen online on stage as well. So he basically goes about to our video just talking about that insights are discovered. They are not designed. So those people who really like design thinking and the intersection with lean and the intersection with agile basically would have certain hard things to swallow here, is that insights require a lot of explorations. Data has to be explored multiple times in different ways and different approaches, and yet you might not even discover what you need to deliver. Whereas design actually has a set of principles that if you follow, by and large, you might end up with something that may or may not have higher or lesser value perceived by the consumer, but it is there. In this case, you don't know what you're really looking at. A discovery might be forcing on your face, and you would still not know that I'm really looking at something interesting. So this is like a very high level, you can say, I don't want to use the word framework, but a high level guidelines on how you would like to take this. So what we just discussed is that you have requirements or user stories I always like to use the word requirements, I'm not very liberal in that, are not really clear in analytics, right? So one of the examples we were mentioning was just this Amazon. So what is the real requirement behind? We're not really sure. We know something related to recommendations, but what specifically we're trying to do with that? It's very, very hard. So it's a not clear requirement. A clear requirement would be something like, how far is the sun from Earth? That's a very, very clear requirement. You know you know the parameters around this, and you know how to work it out. So, but on the other hand, you have data available for certain things, and you don't have data available for certain things. So, for example, it was arguably a very specific requirement, a very clear requirement, that we want to test or validate Einstein's theory of relativity, whether gravity has an effect of time and space. We never had the data for that, because we did not have the technology to capture the data in the first place, right? So what we need to do in Agile Analytics is we need to make sure that whenever we have these requirement challenges in terms of unclear requirements, we have to do these refinement engagements prior to doing our user stories. Sit with your data scientist and really sit collaboratively and really fight on these questions. So what is the fundamental analytics user story we're talking about here? Is it just saying that we need to determine the price of a taxi car ride, or is it something more specific that links with all your organizational information radiators and key performance indicators, if you may? And then on the other hand, you would also like to see we need to farm this data or enrich our data or understand our data better. We use a term called feature engineering, so we need to do a lot of that to basically reduce that gap of what is not available and what is available for us to make this discussion. And anything that does not have a clear requirement and does not have a right data available for that, I would say let's leave that to Darth Vader and the dark side of the Force, for a lack of a better analogy in that. All right? So this is what we were talking about. How far is the sun from Earth? Can anybody tell me, a guesstimate? 93 million what? No ideas. Okay, no, it's just not a trick question. I was just buying time to find out how to fix this mouse of mine. Yeah, so over a long period of time, people have been trying to figure out the distance of sun from the Earth. And then it was a linear cycle, as we discussed in the first slide, about why science is agile in nature, and how we eventually came up with the last month's gravitational waves discovery. It all fell on Newton's head, the apple. So similarly, when we started to find out how far the sun is from Earth, we started with a very simple basic model. Somebody came to me and said, how far is it? I said, yeah, it's pretty far. It's farther than my home, right? That's an answer. That's an analytics model for you, right? Would that help you to take a decision? That's what you want. Or would that enable your app or that user experience that you're offering deliver that value? Recommended courses, recommended movies. It might not be really good in the beginning, but it's relatively there. It's just trying to, nudge things around you in a particular corner rather than giving you a 100% accurate answer that nobody has. So the next time somebody comes and say, hey, yeah, I figured out it's farther from my house and it's farther than anything on Earth. So that's an additional information I can pass on to you, and that might help you in your decision making further. That, hey, I really need to build a rocket ship now if I need to go to the sun. And then the third time it happens when you talk about other planets, that it's closer than to Mars, it's farther to Mars than to Earth, and it's closer to Venus than to Earth, and on, till the time comes that you can actually measure that. So what we have been doing in BI and business intelligence has not been like that. We have been telling people in business world that, hey, wait for 100 of years or a century or a millennium till we really figure out that real question that when can we predict your future, whether you're going to be the next Facebook or not, and then we're going to do something about it. So why don't you just give us a lot of money up front and a lot of resources and waste your time and focus, and we do these big data projects and we just start populating everything in there, and we start hiring these data scientists who just do these numbers in a corner that we don't see. So this is the fundamental thing. But then what happens, like in analytics, Galileo happens. He's not a good friend of waterfalls, because Galileo came up, he said, hey guys, just hold on. Maybe the sun does not revolve around the Earth. Maybe it's the Earth that revolves around the sun. And he really has to run for his life and face all of that history that happened with him. So in businesses, if you're making an analytics app and you're an analytics team within a business environment, it's a much harder sell if you're not really agile, right? If people are not open to a different perspective, if people are not open to learning by doing, if people are not open to experimenting and doing these rapid hypothesis testing, model verification, dumping down and then starting it all over again, then analytics is designed to fail in that model, because nobody can do a linear project in analytics and be saying that this is something that has delivered. It has to be incremental in nature. It has to have all the elements of agility that we talked about. And on the other hand, if you do have these things, then you have the capability of even pivoting to a question that you never thought was important, but it just emerged out of you. That the question really was not to find the linear distance between Earth and the Sun, but the question was to figure out that the better instrument of measuring distance between two planetary bodies is not linear, is their orbital distances. So you really need to understand how planetary objects revolve around each other to really find how things are far or close, because that affects how light hits us and how it reflects back, right? So you're able to redefine the problem statement, and that actually helps you in redefining what you're trying to do. So any questions so far regarding analytics and agile? Now there are some caveats that we're doing. That is something that we have to talk about in terms of saying that not just having that mindset of agility would help us, or how are we going to solve these questions that we just raised, these additional overheads of activities that we would do in a data science project or a feature as compared to anything else, are two things. Over? 1 minute. Okay. So I thought you were playing that game where you have to detect. Great, yeah. So good. I don't want to spend much time of you on this as well. So one of the core technologies that is enabling these capabilities for you to actually go and then create these activities that will help you define your user stories is data virtualization. It's basically a layer that sits on top, and you can change the underlying architecture behind whatever you have, physical storages, Hadoops, non-Hadoop, Storm, Spark, Apache, blah, 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 all those jargons that they throw at you in big data, you can just ask them to keep in and remove them all the time, on and off. But analytics will always be happening on the top, of that virtualization layer. So that's an enabling technology, and if you have that capability, then Facebook, for example, they can start and implement and test, validate an analytics feature end-to-end in one single day. They have that capability, and I haven't seen companies doing that in 5 years even. So some of this has to do with the way they approach the problem, and some of this is their underlying architectures. So virtualization, look into that. Another emerging topic is data lakes. It can easily turn into a data swamp. You have to have some governance there as well, but what data lakes do is that they allow you to do schema on read. You don't have to be a purist to design the best model to represent your organization in terms of a data. But what you do is that you basically say, okay, here's my data, let me try solving my problem by what I have, and my eventual data model designs will emerge from that through an evolutionary process. So these data lakes are all available, and they are starting to see commercial implementations in this region as well, so this is good signs. It's a pretty mature technology in that sense. So I'll leave this thought to you, since most of you are coming from application development backgrounds or teams who are working with apps. So think about data scientists, that these are guys that are better at statistics than most programmers are, and they are better programmers than most statisticians are. So treat them well, listen to them when they say that they don't really know the user story very well. Give them that opportunity to run these extra cycles end to end to figure out what the user stories in analytics terms would mean. And then that's it. Once you have that, you do those provisions for that hardware and infrastructure that would need to run this. It's not something that you can live without, it's something you must have, but that itself would not give you any value, as we mentioned. So that's the pain of analytics you would have to go about. And then just party hard. Thank you. Yeah. Any questions? Yeah.
The project is just starting, you do not have any data, but you do want to give some recommendation based on, like, let's say you're building on the other end of it.
Yeah.
People are not buying books. Can you just randomly generate data and test how you can do that?
Yes, do rapid prototyping, and we have a technique called A/B testing. We always release these control groups and these test groups. to launch these products and their variations to them, and then we see how they basically behave and interact with that. And then based on that, we can actually figure out what that product might even look like, or what that even analytic feature might even look like. Yeah.